Question number 9 says triangle ACD is an isosceles triangle on the ground. So this triangle here, which I'm highlighting in red, this triangle is horizontal to the ground. And the other triangle, which I'm going to highlight in blue, this triangle is perpendicular to the ground. So it's standing straight up out of the ground. And this one is a right triangle. So given the lengths, what is length of line A to B? Okay, well, to deal with that red triangle, really we need a right triangle. So what we have to do is we need to split that angle in half, and that gives us a right triangle here, and that gives us 35 degrees. So I'm just going to redraw that triangle, and maybe redraw it like this. Okay, so I have 35 degrees. Maybe I'll write the 35 up here. Okay, we have our right angle here. The hypotenuse is 10, and what we want to find out is this length here, x, because given that length x, we can work out the lengths in the blue triangle, because if we double x, we get the length of line A to C. So here we have we can use the opposite and hypotenuse sides. So we can say that sine of 35 degrees is equal to opposite over the hypotenuse. And so we can work out sine 35. So sine 35 on my calculator works out to be 0.5735. So I'm going to round that to 74. Okay, and then that's equal to x over 10. So x, we just multiply by 10, so we get 5.74. Okay, so then A to C, the length A to C, so AC then must be double that, so I'm going to times that by 2, and I get double that length, and A to C works out to be 11.47, okay, when it's rounded. Okay, so there's my length, A to C. So then drawing out my triangle that includes AC, so 11.47, and we're trying to find out the height we'll call H, that's the length from A to B, it was the other way around. So that's B and A, that's C, and then we can use this, we're going to use let's use tan, and we'll use 32 degrees. So we can say that tan of 32 degrees is equal to the height over 11.47, tan 32. Let's see here. So tan 32 from the calculator, we get 0.6248. So I'm going to round that to 6.5. And that's equal to h over 11.47. So multiply that by that other length. Okay, we're going to end up with a length of h is equal to 7.168. So I'm just going to round that to 1.7. And so these numbers I have, you might be off by a little bit because I didn't round any of these decimals. I just used the full decimal values. And we've got the length of h, which is what we're looking for, the length of line A to B.